So, my name is Dmytro. I'm a software engineer at a relatively small startup based in Munich, Germany. And today I'm going to talk about our journey to smaller APK size. I decided to do it as a story. And as every single story starts with once upon a time. So, once upon a time, I was interviewing a candidate for Android developer position. And as a part of interview, there was a section for questions. So we allow candidates to ask questions. What do you have, if you have any questions? And his question was really good. His question was, why your release APK is quite big, 63 megabyte? And it was yeah, why is it big? And after that, whoa, it's really big. What should we do with this? It's really a problem. And we started with analyzing. So episode 1, analyzing. Thankfully, Android Studio provides such tool for analyzing APK. If you go to menu builds, pick up analyze APK, you drop your APK for analyze, and you can see what does it contain. So based on that analysis, we found that the biggest part are resources. So kind of obvious, because we usually put images, all the other content, and no one cared at that time. And yeah, so we had to deal somehow with that. And episode 2, we as the developers started thinking what can we do with this? And we came to the conclusion we need to do something with our resources, first of all. So with resources optimization, first point was, let's shrink our video files. So to be more precise and understand which kind of video files we have in our app, just look at this. We use this video for background inside the application. So user downloads the app, and then to get more attraction of the user, we use it as a background. But maybe you mentioned or not, but one of the videos is before processing, and another video is after processing. And the result was the following. So, how we achieve that result? Thankfully, we have a content team in our company, so we simply put all the video files, gave to them, and in a week we return everything back optimized. But the folks who are interested what actually was done, here's some information. So they actually reduced some stream size, decreased the amount of bits. So at the end, the size was significantly decreased of the video. And take into account that this video is shown on mobile screen and used as a background, so on top will be shown a text and additional information. So user at the end will not be paying attention a lot on the quality of the video. And such quality which we got afterwards was pretty good and was satisfying us. And as a result, we were able to shrink APK on 10 megabytes. The other item of kind of resources which we have, it's audio files. Our app is about training, and during training, we notify user which kind of minute of training it is. It's first minute of training, second minute of training, because while user training, they are not watching on a phone, but they would prefer to be notified what's going on. And with the video files, we did pretty similar thing. We took all our video files and provided it to a content team. At the end, we received everything back. But for those who are interested or who doesn't have content team to make all this optimization, this kind of work which was done, and the result was also quite good. So size was shrink for each audio file. The size was decreased significantly. A couple of changes which were made. You can see that the bit rate was decreased, and the video was changed. The audio file was changed from stereo to mono, which gave us such result. So we were able to decrease on 4 megabytes less, which is also good. And the last part with resources optimization was DRAWABLES. So with DRAWABLES, as you already can see, we also got really good result, 25 megabytes. And so here you can see two images. One of them before optimization, another is after optimization. I don't know, maybe like here. Yeah, shouldn't be like mentionable. And take into account that those images also like used as a background inside the app. So as you can see, like first image is like PNG and almost half of a megabyte, and the other image is GPG, which is like less than 100 kilobytes. And the result was like really good. So with drawables optimization, we came to conclusion and to build some of the rules for what we actually achieved with the drawables optimization. One of the things is we removed all the unused drawables. Sometimes it happens that team is getting new drawables, putting it more and more and more, and simply like all drawables are getting forgotten. And for such things, there is like a link which gives you warnings that there is something wrong. If you configure like ProGuard, so not include all the unused resources, it's already like helps you a lot. Second, we did some research and came to conclusion that basically in the app it's enough to use 3 densities: HDPI, XHDPI, and XXHDPI. Like there was like some paper somewhere like from Google that more than 90% of devices are exactly with such density screen, and this is already like enough to have. Then one more item is to use the JPEG when possible. Like if you don't need the transparency, like alpha channel in your images, then use JPEG. Otherwise, prefer to use WebP instead of PNGs, because WebP is a new format from Google, and it simply uses less memory, less disk space than PNGs. After that, we also discovered a couple of rules which we set up for our team. It's like, so for all the drawables, we defined that all the drawables with HDPI should be around like 50 kilobytes, and for all the others, like for XHDPI, 100 kilobytes, and for XXHDPI, not more, around like 150 kilobytes. Then was time to review. And as a review part, we use the same tool for analyzing APK. We drop like new APK, and as you can see the result, the result was like significant. We were able to achieve 24 megabytes. And also like what you can also do is to put all 2 APKs to compare them. This is what we did. And from this comparison, you can see that the difference is pretty significant. Like we're able to achieve reduction size 39 megabytes. Meanwhile, you might also see that we started using more Kotlin, put more other libraries, so on. Learnings which we got from all of such things. One of them is, as a developer, we have to pay attention to resources, like which resources we are adding, if they're big enough, if they're small enough, if are they enough optimized, and so on. Because at the end, we are caring not only about writing the code, but more about the final product, how it looked like, and how everything will be working. And another point is collaborate with designers. Sometimes designers are like really passionate about their work, and they put in like pixel perfect images and so on. But you receive this image like for XHDPI, and it's about like 1 megabyte. And like designers simply cannot know like what do you expect. So just come to him, come to the designer, him or her, and discuss like, look, we are going to use this image as a background. It will not be used as a full screen image. And then it will be just like a third part of the screen. So we might not need to have like really high quality pictures there. Let's make it with lossy quality, but it's already enough. Users will not be seeing the difference. New hope. Why I call it? Like we started analyzing, what can we do like in future? Which kind of future steps we could do? One of them, we could split our APK by screen density. Another, we could split APK by CPU architecture. And one more point, we could add like automatically check size for each each new file. So whenever you add new file in pull request, we're going to do like check if the final APK like changed or not. Then Google I/O happened. Everyone has likes Google I/O. It's a really cool event. All the time coming some new things which we'd like to try. And one of the new things which was introduced during Google I/O was the app bundle. So app bundle is a new format for distributing your installation file. And what does it? So like at the end, when you're ready to distribute your app and to upload to Play Store, you, instead of like assembling an APK, you assemble like application bundle and upload to a Play Store. And then like on a Play Store, when you go, like when the user is going to download this file, it will be like analyzed and based on user configurations, for example, like screen density, will provide an appropriate APK, which will be having only like resources for that screen density and nothing more. In order so there is like bundle tool to test everything, and if you'd like to test, you just need to provide JSON in the following format and specify like those properties. So in our case, like splitting by CPU architecture doesn't make any sense because we don't have any native code support. But like splitting by locales and splitting by screen densities makes totally sense. And here, like I was trying to experiment with okay, let's split like by locale, like supporting English and the German locales. And splitting by screen densities, in this case, was like, I guess, like X HDPI, but I also played around and provided different values for HDPI and for XX HDPI. And at the end, what we received, so with the following case, you'll get like a folder with like folder with three APKs, which will be like at the end zipped into one APK. And those three APKs contains the following information. So first of them is like the base EN APK. It means it contains only string resources, only like resources related to that locale. So in our case, it was like just 52 kilobytes. Interesting point that for German it was like almost double the size, and the reason is quite obvious because all of the like words in German like double sized, and then like even if you have like book written in English and then translated German, like the size of the book will be increased almost twice. Then another APK is base master APK. Base master APK, it contains like all of your logic of the app. So it contains like DEX files and the resources which are not localized, which are like used for everything. And the last APK is the base HDPI APK, which contains only HDPI related resources to that. So and then you'll get like HDPI APK, then I changed the density to support XHDPI, and then changed density to support XX HDPI. And you can see that what changes only the size of APK related to densities, but nothing else is going to change. And if you summarize the size of each APK, you can see that even like with in case like XX HDPI, the final size will be around like 19 megabytes. And the case before I showed like that we were optimized, we got like 24 megabytes. So even like in this case, we are benefiting. Like even user has really like a good screen density, XX HDPI, he still gets like smaller APK during downloading it from Play Store. I call this episode Random Data because we were inspired to shrink APK size based on the research from Google saying that if you make APK smaller, then you might get like more installations, more registrations in your app, especially from emerging markets. So we had a hope to do that, and here's some data. So this chart is showing amount of registrations in the following countries like Egypt, Indonesia, India, Mexico, Malaysia, and Taiwan. For like in a time period around 2 months. So after we reduced APK size, we analyzed the time period for 2 months, and actually we didn't see any positive trend. You can see the such spikes, they are more related to featuring app in a Play Store, but there's nothing impressive, unfortunately. Maybe later, we'll keep an eye on the analysis and check time to time if the amount of installations and registrations as the app is increasing. But at that time, we didn't see anything. And my last episode is, why I call it like this? So we faced exactly the following issue. I can tell you why, because we're working on a cross-functional team. So we have around 10 Android developers, 10 iOS developers, backend developers, designers, but all of them are split together in teams. So one team has 2 Android developers, 2 iOS developers, a couple of backend developers, and we have 5 other same teams. And during the week, it can happen that one team doesn't know what other team is doing. So in this case, it was exactly like that. So our team was trying to reduce, optimize resources, do everything what's possible. And meanwhile, the other team was keep adding resources which are not optimized, big images, big videos, and yeah, there was a problem. And exactly, it was exactly like that. And we thought yeah, we need to stop it. And we came to conclusion, one of the possible solutions would be is to do a check of the APK size on each pull request. So you create pull request, and we added the following script, which after assemble completed successfully, takes APK and analyzes to APK from master and checks if the threshold was exceeded. So we set up a threshold, for example, 27 megabyte, and your pull request, your build on pull request will be passing if your release APK is still below 27 megabytes. In case it's increasing, your build will be failed. So again, it's not that bad. You'll see that it is actually something wrong with my pull request. I might need to do something you need to adjust threshold, or maybe you need to optimize resources. But at least it's a red sign that something is wrong. And in case folks are interested in getting such script, there's a link below. You can go there. The script is available on GIST, and feel free to use it. And then I'll provide also speaker deck, so you can go and check it. So it worked for us. This you can see the part of analysis from our CI tool. That APK size is now like that. It's still satisfying the threshold. It's okay. Here's the resources which I used. A couple of them official documentation. The last two is 2 my blog posts which I wrote on Medium. They kind of split about same topics. One of them is about optimization, another is about app bundle, how everything is organized. Feel free to check it out. And on this note, I would like to thank everyone for listening.